Good evening, sir. Shall we start the session by 6:05, sir? 6:05 p.m.
Good evening, Madam Sharma. Whenever you are ready.
Okay, sir. Thank you, sir. Good evening, sir. Shall we start the session, sir?
Yes, ma'am.
Good evening to all. On behalf of Karpagam Academy of Higher Education and the organizing team, I would like to welcome our resource person, Dr. S. Santhosh Paramasivam, sir, Assistant Professor, University of Cagliari, Italy, for the AICTE ATAL Online Faculty Development Program on Harnessing Artificial Intelligence for the Future of Wireless Communication and Signal Processing. He is a distinguished academic with over 15 years of expertise in sustainable energy systems, intelligent sensor networks, power electronics, and AI-driven modeling. He plays a pivotal role in PNRR Pattern project, leading software architecture, AI modeling, and the integration of low power sensing and imaging technologies to strengthen resilience in urban environments. This research spans AI-based assessment of life energy storage, micro energy harvesting, and wireless sensor networks for environmental monitoring, which also fostering international collaborations through Polylab and supervising postdoctoral researchers under MOST project. With more than 30 peer-reviewed publications and multiple competitive grants, he has made an impactful contributions in renewable energy management, environmental monitoring, nanomaterial-based sensing, fog edge computing, and smart mobility systems. His written outputs include IoT-based sensing architectures, PV optimization, and LoRaWAN-enabled marine monitoring BIOS, directly supporting climatic risk sensing and sustainable infrastructures. Along his industrial leadership, at Electrosol India, where he designed EV battery test system and ICT platforms. He has held key academic roles as cluster head, accreditation coordinator, and curriculum designer. Through invited lecture notes, keynotes, and journal reviews, he continues to advance AI integrated sensing and energy systems, which drives European transition towards adaptive climate resilience urban infrastructures. Once again, thank you, sir, for accepting our invitation. I welcome you all. Welcome you, sir.
Good evening and thank you for the nice introduction, ma'am.
Thank you, sir.
I would like to start my presentation. The general topic or the overall topic that has been given is AI and ML integration in hardware and communication systems, which I would like to narrow down to advancing smart sensor network with HAI and energy harvesting systems. So here is the presentation outline, what we are going to see today. So to start with, we will have a small introduction and then the motivation for the purpose and smart sensor networks, HAI in sensor network, then energy harvesting in IoT, necessity for energy harvesting in HAI, and a proposed architecture for the entire system, followed by application areas and the current research, the technical challenges and emerging solutions, finally with a test case. So this is going to be the flow for today's presentation. So to start with, introduction. So why smart sensor network, or what is a smart sensor network? See, when it comes for the present scenario, everything is IoT. Every device is an IoT device, and the number of sensors that is every device consists is numerous. Actually, if you consider your mobile phone, we literally do not know how many sensors we have in our mobile phone. If you install an app called as sensors, you will know that we have an accelerometer, gyroscope, and many other sensors in our mobile. In the same way, we have smart watches. There as well, we have numerous number of sensors. Likewise, when it comes for applications are concerned like smart cities or industry 4.0, now even we are moving towards 5.0 and environmental monitoring kind of things, we require more advanced sensing network to ensure that we have a perfect data set. So for this, we propose the smart sensor network. And it is estimated by 2030, we will have somewhere around 550 plus billion IoT devices. But one key issue what we would have is powering these devices. Right. More than the data. Yes, of course. When the number of devices increases, automatically the number of data information that is being collected is going to increase. But more than that, the power requirement for these devices. You just imagine your battery or your mobile phone has a capacity of 5,000 milliampere hours, a minimum of 4,500 to 5,500 milliampere hours is the battery capacity of your mobile phone. Wherein, how long is it capable for your mobile to have your charge, hold your charge? It's maximum 1 day, right? Not more than 1 day. Maybe 24 hours to 30 hours is the time duration to which your mobile can hold the charge. Give me a minute. Sorry for the interruption. So powering these devices is going to be a big task or a big concern which we are going to face. Point number one. And then again, the data. These are the two main concerns of all the smart sensing devices or whatever sensing devices. You even forget about sensing and smart sensing. Even when you consider your smartphones, If you see every now and then, probably within an year or two, maximum of 3 years, everybody has to upgrade their mobiles. What is the reason for upgrading a mobile? Is it gonna be primarily for camera? Yes, of course, there are people who just upgrade their mobile phones for camera, but most of the people who literally use the mobile as a device for their official work and all other things, they upgrade their mobile for two reasons. One, the storage would have been completely filled because of the updates of the installed apps and other storage devices. And the other thing is that charge. The mobile phones are unable to hold the same level of charges which they were able to do over the initial days. So these are the two main concerns. This is a concern for all other applications as well. And moreover, when you consider when you consider the power requirements, this is not only about the mobile phone battery, and also if you think recharging a mobile phone every day, you are recharging your mobile, right? Likewise, when the number of devices increases, automatically the power requirement for these devices, the grid energy requirement also increases. So this is again in one way or other depends or affects the grid network. So these two are the prime is your power, and the second one is again the data storage. So if you have to send data, so every now and then, if you're sending data to the cloud or some main storage system, then it has to be keep on increasing. But all those data are necessary. Is all the data necessary? No, not all the cases. In not all the cases, all the data are necessary. Maybe see, for example, if you consider of monitoring a temperature of a certain city or a particular place, the temperature is going to remain same for the whole day. No, maybe you will have very few changes. But when you acquire data for every 10 seconds or 20 seconds, you imagine the number of data you collect for a single day and about for a whole year. And then when it accumulates for 10 years, what about the data? But of course, data is essential, but do we need all these data completely? No. So these two are going to be a big concerns in the days to come. That is why we propose this edge sensor network. That is why we propose edge AI system, point number one. And the second one is energy harvesting systems. So moving forward, as I was saying, the motivation was limited battery life, latency in cloud processing. And the third one is scalability issue. These are the things why or what forces us to move towards edge AI systems. Moving forward, what are the components of these networks? We need three things. One is your sensing system, processing, and the communication system. Wherein, whatever our requirements, it should be a low power consuming, and then multimodal network should be there, and it should be adaptive as well. So these are the three requirements. So the three components will be sensing, processing, and communication. You may think, what or why are these being spoken? Here, the most importance is that these are not like general sensing, general process, general communication. In all these cases, our prime focus is of low energy consumption, especially in sensing devices, processing devices, as well as the communication network protocol is concerned. Yeah, of course, we have numerous number of communication protocols. We have Wi-Fi, we have LAN network, many things are there, but nobody is concerned. This is what I'm trying to say. Nobody is it. Mostly, we don't concern about the power consumed by the energy, that is the data transmission that is being done. So, how much is the power required for sending a data through a Wi-Fi or a Bluetooth or another? We never worry about that. But when it comes for large or huge number of continuous data transmission, reception, these are supposed to be one of the factors which we have to consider. So, for example, if you consider an RF transmission, radio stations are running for a whole a lot of time, 24 bar 7 nowadays. But do they consume that much energy when compared to a television station? They are running both video and audio. What is the difference there? Here it is only audio, here it is only video. Video and audio. Is it that only the case? But when it comes for video is concerned, you have HD, you have a lot of variations are there. Like the same way when it comes for your networks, mobile networks as well. Starting from 2G, today we are moving towards 5G. What is the G differences? 2G, 3G? Yes, of course, generation differs. Automatically, when the generation differs, the speed increases. How is the speed being increased? because the bandwidth is increasing. Okay, is that all alone? Is it not affecting anything else? So these are the parameters which we have to consider when it comes for a smart system is concerned. Because when you go for everything as a smart, on a down the line, everything needs more power. So this is one important factor which is a very high concern, which we are going to deal in a very short span of time. Fine then. Fine. What is the benefit of moving towards the proposed system is that the first thing is you will have a low latency, you will have a reduced band and privacy preservation as well. So how are we going to do this? So we can go with either tiny ML models or lightweight CNN and LSTM models. These are something which we can focus on to get our work done. Right. The next part is energy harvesting part, because earlier we were speaking about the communication protocols, we got a solution. But now, energy harvesting part, how are we going to take care of the energy harvesting part? We have vibrations, the solar, RF, and thermal. So these are the four primary sources which we would like to consider for energy generation. Of course, all these becomes green, clean, renewable energy sources, which will not affect the environment. So this is, of course, a sustainable solution as well. So when it comes for, you may ask, are these proven? Because solar, we are very much aware about solar cell or solar photovoltaic plants, which is available. What about the vibration on RF and thermal? See, when it comes for the vibration is concerned, there are countries which have already installed vibration-based energy generators in their roads, which are generating energy, the pedestrian paths and things, which are generating enough energy to power up their solar, the street lights. Of course, therefore, it is a proven technology and can easily be adopted. And we are very much aware of our solar as well. RF is also available nowadays, and also thermal. Thermal is nothing but thermal here. What we mean by thermal is the thermionic power generation. That is what we mean by thermal here. And the most important benefit of going for this is that these have an extended lifetime, and then these will act as batteryless nodes. How come it is going to be act as a batteryless nodes? We will see in the next slides to come as well, right? And then for this, for example, for if you want example, you can have it as piezo based and vibration based. These two are prime sources which we would like to focus as an extended lifetime and batteryless nodes, because these gives energy 24/7 whenever there is a vibration. Let's say, for example, if you fix it to an automobile, say your bus or a carriage system or a car, whenever it is moving, whenever there is a vibration, irrespective of the time of a day, it is going to be its power generation is going to be continuous. Wherein when it comes for your solar or thermal, there even we have some disadvantages, but when it comes for these two kind of vibration energy generation, these are going to be a continuous one. So are these whatever we are proposing just like that? Are we proposing? No, we have developed a model. This is the total smart monitoring system which we would like to propose, or which we have done. In this, you can see that when it comes to this, we go like this. Let me take a pointer so that so this is the architecture of the proposed or the developed system. You can see this is a single node what we have proposed, self-powered sensor network. And then similarly, we will have multiple nodes which will be connected to a gateway, and from there the data will be stored to cloud. But again, you may ask again the same you're proposing. You're having something sensor node and you have a client, you have a cloud, everything is same. What is the difference in here? See, the important difference or the uniqueness of this is that, see, you can see here, this particular network is gonna make use of something called as Bluetooth low energy network. That is the point number one, right? You can see we have BLE modules, which is gonna be transmitting data from your sensor nodes. So first thing is that the network is gonna be a Bluetooth low energy network. One. The second thing is that here you can see here we have something called as solar or energy harvester control block, to which we have some energy harvesters, solar cells and thermionic cells, which means this particular sensor node is going to be powered with the help of these energy harvesting devices. And then you may ask, okay, fine, then what about the night time or when there is no energy, what you're going to do? Here comes the role of the supercapacitor. The energy storage device, what we propose here is that instead of lithium ion batteries or some other energy storage, we propose a supercapacitor. The supercapacitor, what we have in here, is capable of storing up to 10 amperes. Even if you want, you can go for 15 amperes as well. So it depends on your power requirement. But as far as our design is concerned, the total current consumption by our device is a maximum of 30 milliamperes for the communication. That is when it sends data. That is the time when the entire system consumes more power. So that is 30 milliampere. And apart from that, when the system is in sleep mode, that is when the sensor mode is in sleep mode, it consumes an energy of 6 microamperes. So the minimum current requirement will be 6 microamperes and the maximum current requirement will be 30 milliamperes. This is the energy requirement of the system. So 10 ampere could even last for a whole week. Even if there is no solar for one whole week, we'll be able to manage this capacitor. This is the proposed architecture which you see in here. And this is not the level of alone architecture. We also have developed a custom board which is capable of connecting all these things. And what is the speciality is that this is not something very much confined or to something specific. This is a very generic architecture which we have developed so that whatever application you want it to be used with, you can use. So how come it becomes generic is that the first thing is that so this as an I2C communication wherein you will be able to connect up to maximum of 24 sensors. As of now, we have connected only one sensor, and whether you connect one sensor or 10 sensors, the data transmission is gonna be the same. There is not going to be any change in that. So even if you connect 24 sensors, the data transmission, the energy requirement for data transmission is going to be only 30 milliamperes to maximum 50 milliamperes maybe. So that will not change. But when it comes for the sensor is concerned, based on the sensor, the total power requirement will change. That is one aspect we have to consider. And then as I said, we can connect up to 24 I2 sensors which can communicate with I2C communications. And also, if you want, you can connect an accelerometer or gyroscope. Whatever you want, you can connect it. We have provisions for that as well. And then next comes the BLE module. This is the data transmitting module. It again transfers data with 2.4 gigahertz bandwidth. So this is adaptable even with any Wi-Fi network. So then comes the part of the energy harvesting. As I told, here we have made provisions to connect 3 energy harvesting systems so that in any means, say for example, you can connect a solar, you can connect a thermal, or you can connect an either external supply or another air vibration harvester or something, whatever you want. You can always go with 3 different sources. So that is one advantage we have here. And this part is supposed to be the energy or the supercapacitor part, which takes care of automatically takes care of the power requirements. Moving forward, so this is the developed board. You can see the left hand side is gives the details about what I was telling you so far. On the right hand side, you can see that the image on the right hand side is the fabricated board, which is already having all these components. Provisions are given. We have not connected the yes, of course, we have connected the supercapacitor. So these things, the backup part, energy storage part is already built, as well as the Bluetooth device is also fixed, so you can directly get the data. Solar or energy harvesting parts, we have ports are available. You can connect whatever energy harvesting methods you want. When it comes for the accelerometer and then gyroscope part, we have left connections available. If the user want, they can just always connect and use it. And then moving forward, what is the speciality of moving towards this particular BLE BGM 220? What is the features is that? Here you can see this is a low power mesh node and it has a maximum power transmission capacity of 8 dBm, and then it has a 512 KB of flash and 32 KB of memory, and also it has a 32-bit ARM Cortex processor, 76.8 MHz. All these are its general features. And also when it comes for the current consumption, you can see that what the maximum is 4.3 milliamperes for RX at 1 Mbps speed, wherein 10.6 milliamperes 10.6 milliamperes current at 8 dBm output power. So you can see that the current requirement for data transmission is very less. So this is one important thing why we prefer to go for this. And you may ask, you were telling that the power requirement for data transmission is 30 milliampere, but wherein this board requires only 10 milliampere. See, the 10 milliampere power is for this particular board to data, send the data. But wherein, when it comes for the sensors, we have to collect all the data. The total sensor current consumption also I have included, I'm saying that. And also you can see that this has 1.4 microamperes in a deep sleep mode. The 6 microamperes which I told includes the current requirement for the other sensors as well, which are included in the system. So moving forward about the energy harvester part. So this is the energy harvester which we have used in that, which is an LTC 3105. What is the speciality of this is that this has a minimum startup voltage of 250 millivolt. So when there is a 300 millivolts of supply, automatically this energy harvesting starts. And this is integrated with an MPPT, so automatically it can start operating, and then you can see, you can very well see that it has multi port connections. In the sense, this same converter configuration will support you for PVs, for thermoelectric generators, as well as fuel cells. And the operating range of these particular systems also, you can see it is minus 65 to 150 degrees. So this way it is very much easily adaptable to any climatical condition. If you want to keep it in outdoors or indoors or a cool place, irrespective of the geographical location, irrespective of the climatical conditions, you can use this at any place. That is one important reason why we have chosen this. And then you can see the peak current is 0.5 amperes. That's very less. So you can easily manage the system. And as I was telling, we have preferred three solutions. We have tested three different models. One is a photovoltaic module, and the other one is thermoelectric, and the third one is vibration energy generation. But wherein in our application, we have gone for only photovoltaic, and this is the entire setup. Wherein here we have gone for only two things. One is here photovoltaic, the other one is thermionic. Because as we have selected this particular, or we have utilized this for some static application, or the application does not have a enough vibrations that is being generated in the place, we were unable to generate energy with the vibration harvester. So we have not preferred that for this application. When we have used these two, and we have successfully collected data as well, generate energy as well. This is the energy storage system, wherein here again, the benefit or beauty is that the input range is 0.7 to 5.5. It has two modes of operation. One is your buck and boost, wherein Microsoft Boost, it is capable of, even though you have 0.7 volts, you can get a minimum of 2.7 to 5.4 with respect to the mode which you are going to use it. And then also the output is 2.5 milliamperes is the minimum current, can give you up to 600 milliamperes, can give you in charging as well as in discharging. And it has four modes. One is your bypass mode, the other one is disable mode, apart from the buck and boost mode. What is this bypass mode and disable mode is that, as I was saying earlier, whenever there is we just saw the energy harvester right here. So whenever we have these energy harvesting systems that are acting or that are working, this energy harvester will directly supply to the load requirements. So in that case, your supercapacitor or the energy stored in your backup device will not come into picture. So only when there is no source, then they will come into picture. So for that particular case of operation, we need some way to bypass the supercapacitor or the energy storage device. So then the mode here is being used for that. The bypass mode is being used for that. So apart from that, we are very much aware about the buck mode, which is for charging, and this for discharging. And disable mode is, it is totally disconnected from the system. So it depends. Whenever you want to work at the circuit level or you have to do some modification, you can set this in the disable mode so that this particular part will not discharge anything to your board when you want to do some technical work with your modifications kind of things. That's what I mean by. So moving forward. So why we need why we need it? Necessity for energy harvesting with HEI. Why do we need this combination? As I was telling, so here where is this HEI comes in? That is what your next question will be. See, the module which I have been showing you here will get all the data, which will get all the data and send only the necessity data, or say for example some kind of log kind of thing. I'll show that in the later slides which I have. So which means that it not or immediately or every single data will not be sent. So what is the difference between that and sending individual data and a log file is that, so when you send individual data, every individual data will be saved as a different logs in your system. Instead, if you send a whole log, or for example, one file for a whole day, one notepad, anyhow, you have to send data, right? In every now and then when you send packets, automatically they will be stored in some locations. If it's the same way, when you consider it as a whole day, then you can just filter the data and see that you can just avoid the repeated data. Okay, this is the data, like for example in the morning at 7 a.m. it is like 5 degrees or 60, say for 20 degrees of temperature, and then at 7:30 it became 21 degrees. Likewise, you can just filter out the data at your core system, and then you can send only the fine values which is required or which is needed uh, for the future data observation. So that way, your edge system, edge means the system, edge node or the end node is what is called as edge node. This way, we will be able to maximize the efficiency of the nodes. That is where this part comes into picture. And then when you see, when you have an energy harvesting system, if like the previous case, if you want some external source of battery or something else, every now and then, say for example, 1 year, once in a year, or once in 2 years, or once in 15 days, or once in 30 days, with respect to the size of your battery, you have to keep on changing the source of the battery, or the battery has to be changed. Wherein when you have such a system which is capable of generating energy on its own, and then we have some backup which will take care when there is no energy generation, and we have some communication network which is going to be a low energy network. So when this is like a complete system is available, you don't have to think of maintenance, because that is a very big concern. You have to, more than the installation and equipment cost, the maintenance cost is one important factor which kills. So you can just forget about it. So you can forget about it, only consider or focus on data collection. So this will last, maybe let it last for 5 years. So one time installation will work for 5 years. Let it be 5 years. 5 years you can be calm and you can just focus only on the data collection part. So this way, this is sustainable, this is energy efficient. So all these things, that's how it goes. That's the necessity for us to go for such a device. And when it comes for the architectural requirements, what is the architectural requirement is that we will need a sensing layer, and then we will need an edge intelligence layer, and then energy harvesting and management system and network layer. So the 4 layers we need, and already we are very much aware, or we have these. It is not something new we have to develop. We have to just consolidate these things which are already available. So in this way, it will make our work easier. Moving forward, when it comes to the applications are concerned, as I was saying, there is no limitations of the sensors that can be connected. Only thing the sensor should have is an I2C communication protocol. When there is an I2C communication protocol, when the sensor supports an I2C communication, automatically you can move on. You can go with any sensor that supports your I2C communication. So application part is concerned, again, you can go for grids, renewable energy plants, predictive maintenance systems, and industry, smart industries, industry 4.0, energy supply chains, effective monitoring, and especially our infrastructure. When it comes to urban infrastructure, smart cities, you can go for traffic, air quality, bridge, and geological surveys, volcanoes, geothermal energy monitoring, and then a lot many things which persons cannot be deployed for monitoring system, monitoring continuously, and as well as pollution and the application is infinite. So what is the current research that is in progress in these areas that hydro turbines. HEI in hydro turbines, wireless sensor networks, and batteryless beacon systems, and then we enable vibration filters for smart roads. These are the current research which are in peak, which are a very good future progress as well. What are some technical challenges that we have as of now? It's like here low power AI interference constraint modes. So how when you deploy your AI system, again as I was saying, suppose we level low power consumption, all these things are fine. How far are we going to consume power? Because when it comes for a small system data, that is very much fine. But when you go for some high computational requirements, say for example, the system what we have seen is just sensing system. So here there is no computational requirements is there, or it's very simple. It is just going to collect data from the sensor, it's going to accumulate it, and then effectively it's just going to filter the data and it's going to send. So even if you use a maximum of 24 sensors, you will get 24 single data. 24 single data maybe for 1 minute. And then if you consider it for a whole day, the data requirement is here in this particular case is less. But when it comes for some tedious applications, when you use a high-end AI interface, then how are we going to manage that? That is one thing we will have an issue. And then, of course, as I said, we will have a continuous energy generation. All these things are fine. What if there is some intermittency? So that is one part we are not yet aware of, because as this is all new proposals or new ideologies we are developing and trying to do this. These will be some technical challenges we would have. And also, as I said, this is utilizing to flow energy, the network scalability and security. When it comes for higher data transmission or higher AI involved systems, we will have issues there as well. We will not have issues, but we have to look into those part as well. How are we going to go for the hardware and software co-design? That's well, these are all key challenges. Of course, the idea is good. Of course, it is possible. Of course, it is scalable. It's feasible, but still, we will have some endurance in these areas which needs focus based on the applicational requirements. So, the solutions for this could be we can go with some tiny ML and model computers, hybrid energy storage systems, then federated learning ranges, the AI-driven energy management. Again, everything comes back to AI and as well as the power requirements. So it's concern aspect, and future directions could involve around the self-sustaining sensor ecosystems, integration with 6G and H cloud, circular economy, maybe second life batteries we can use, it will be better. But even then, the SOC, SOH, we will not be able to have a clear picture of those. So here we have an overview of smart sensor networks, evolution, then HEI enhances intelligence, and then energy harvesting system ensures stability. These are the conclusions of this. Sorry, these are what we have seen so far. Together, when you implement a system with all these things, definitely we will have a resilient and scalable IoT system. So that is what we would like to conclude here. And these are all not just the this is not just an ideology what we have developed, but as well we have implemented this to test the system. We have implemented this on a scooter, and then where we have enclosed an energy harvesting system, and also a sensor monitoring system, wherein here we have used a single sensor, as I told you earlier. We have used SDC41, which is capable of getting temperature, relative humidity, and as well as the pollution data. All these three data we have acquired, and then we have stored it to cloud, and also we have solar energy based harvesters. So solar energy harvester as well as thermionic energy harvesters, two things we have installed in this bike, and we have tested, and it gives a very satisfied results. So to ensure that why we have preferred this particular application is that As I was telling, we wanted to try with the vibration-based analysis also, but wherein in this particular bike, the vibration was not so sufficient enough to generate electric energy, because here the vibration is very, very less as it's an e-bike. But wherein we were able to do the static part, stationary version also. When it is moving also, we are able to get data, and the data transmission part. All these parts we were able to identify, we were able to get satisfactorily, and then it is successful. It is in a simple, a successful approach what we have ended with. So this is the sensor what we have used, and the data. These are the data we have collected from these data and then stored in cloud. And for this, what we have used is that we have used a Raspberry Pi for this purpose. Since we have used this Bluetooth module, and then Bluetooth we have connected in series with, and through serial communication we have connected a one Bluetooth module to the Raspberry Pi. So the Bluetooth module will just establish the PLE low power energy network, and from there we just collect all the data, and through this particular gateway we will just send it to the cloud. So this way, those Bluetooth modules, Bluetooth low energy networks, and Bluetooth sensors are our boards. That is each board what we saw. Each board serves an AI node, and as well as the energy requirements. Sorry, the data transmission is taken care by the Bluetooth low energy network. So this way, the transmission or the communication energy requirement is also reduced, as well as the other part is as well. So this is how it goes. This is a test case. Right. I think I just finished so fast. Right. So this is our test case, what we have done. And then this is actually these things we have done under a project return, which enabled us to explore many things on the environmental monitoring and the sensor development. The other key enhancements or achievement what we have done with these is that we are in the progress of developing an antenna, Bluetooth low energy antenna, which already we have succeeded with like 150 meters of data transmission. By general, it is 75 meters is the range, 70 to 75 meters is the maximum range that we can attain. But wherein we have developed an antenna which now we are able to send the data up to 150 meters. But it's only a bidirectional antenna, and still we are working on it. So to ensure it become an we are working on it to make it an omnidirectional one as well. This is what I was planning, but I don't know. I just have finished very fast. I think I still have a lot of time. I think so. Maybe if you have some questions, we can just discuss. How long do we have, ma'am?
Sir, 7:30, sir. 1.5 hours, sir.
Okay, so still we have 45 more minutes. Wow, yes, that's a very,
Sir.
very big time. I just moved on quickly, I think. So
Can you share any other examples?
some other examples you want, ma'am?
Some
Sure,
other
let us.
examples or some other your work what you have done, so that if you would have discussed means it will be very
Yes.
useful for us to
Yes, of course, just that can be done. Maybe that will be a good idea as well. So give me a minute. Let me see what I can share.
Okay, sir.
Maybe I can just share why we actually went for this kind of approach, or why we went for the smart sensor network, or why we had the necessity of building all these system. So maybe I can just give you an overview of that, why we went there, because it all started with this, wherein when it comes for a country like India, we don't have any impact of energy or global climate change. We still don't feel them. We had a single solar thermal effect, right? In the last year, heat waves. We just have a single heat wave in the last year, but wherein if you see countries like Europe, we have a lot of such climate issues here. That is why we very much we are focused on these sustainable goals. Sustainable goals when it comes for country like India, we just say it as okay, we meet this goal, we just, but here literally they strive for each and everything. Literally, actually, the health is the prime importance what is being given here. Then the work, people prefer that here the work culture is far better when compared to other countries. The main reason is it is not that they are not willing to work. It is because health comes as a first priority. The entire month of August is a holiday here. The entire month of August. People literally say, okay, they are very happy because it's a holiday. No, it is actually a summer. They cross the Europe, you will not be able to find anybody working during that period. So during that time, they just get exposed themselves to the maximum possible sun. That is why always in the summer they go to the beaches, they lay there for the whole day, because in that way they acquire the vitamin D from the sun, so that they will be able to manage the winter that is coming up. So this is a key health concern which we are not aware of. And also, when it comes for a disease called as cancer is concerned, countries like Asia, most of the countries in Asia, the only cancer most of the people we are very much aware is like a blood cancer, the throat cancer. These are the two things which people get affected with. But when it comes for these European countries, the most important part is the bowel cancer. Most important disease these people are getting affected is bowel cancer. And not like every individual, see, you can just can go out and eat anything whatever you want, but it is not possible for the people who live here. Each and every person has a different health condition. They cannot consume, some are there who cannot consume milk, some are there who cannot consume rice. So likewise, each and every individual has a unique health structure, unlike this Asian people. So therefore, here they give much importance to health. That is from where they have all these criteria, 7 goals they have framed based on the European conditions. These sustainable development goals for people from South Asia or Asia, it's just they are just an open or overview. But when here it is their daily life. The fertility rate across Europe is getting down. There is numerous energy generation is there, resources are there, there is resource, financial resources and other resources are available here. But wherein when it comes for the basic needs, it is not there. There are many villages, there are many cities which has a very few population. That is why you can see that if now many of the European countries are inviting people from abroad to come and stay there or settle down. That is because the number is coming down. As a normal day for people down there in Asia is not a normal day for people in Europe. So that makes a very big difference between, that makes a very big difference for them. That's why they are meticulously work. That is why they are meticulously working on all these aspects. They are spending huge amount of money for towards these 17 goals, especially for clean water and sanitation, and then sustainable cities and communities. These are the areas where they spend more than affordable and climate energy, clean energy. So these are all some important factors, or these are the main factors which forced people to move on to research in different areas. Like the project which I was doing was a return, so resilient multi, because here the other part is natural disasters. When it comes to natural disasters, the only natural disasters we know is rain. But here they have volcanic eruptions, landslides, cold winters. So it's terrible. To overcome all these things and to have a sustainable living, or as I was telling you, a normal day down in Asia is not a normal day here. You have sunlight or you have the day night pattern all along there the same, wherein here the pattern is different. Here they have a concept called as daylight saving, which wherein for 6 months the time lags for 4.5 hours, the other 6 months it lags for 3.5 hours. This difference they have in their regular clock to ensure or harness the solar energy or the sun power during the day. So these are all weird things which very weird for us, but very yeah, they are all very, very critical. And then this is critical here. That can be only realized when you come here and then when you live the life here. So it's not so easy like what we see from there here. And then this is what makes every research essential. And the earlier presentation which I was giving you about the recent network and all other things seems very simple for us, but the applicational areas in which we have been using here, or for what we have designed them, is all especially for the monitoring of the climate. Here it suddenly changes. You can't even imagine. It will be very hot outside. In another 5 minutes, it will be raining. You don't know when it will rain. You don't know when it will be snowy. You don't know when it is gonna become dark suddenly. So here it is very, very unpredictable. So to have a clear prediction of how it works, that is where all these systems comes into picture, right? So, and first of all, what is weather and what is climate? Weather represents to the daily atmospheric temperatures, yeah, how it is going to be, whether it is going to be rain or this is the daily weather. When it comes for climate, it is term for a long-term study of the daily weather is what is climate. That is why they say it's just climate change, how it has changed, how the weather, the daily weather has changed. Say, for example, 10 years before it was not the same what we have today. Now, even in India, if you see especially when it comes for South, earlier we had the summer in the March, April, and May. Now, by the end of February, we have the peak summer. Summer starts by the end of February, and then March we have our peak summer. April we have our peak summer. May sometimes it start raining nowadays. So this is a shift we have. Why the shift is happening? Oh, because here it is very rapid. For us, it does not impact much, but here it impacts in a very high range ratio. The ratio is higher. How do we know the climate change is real or what is happening? The first thing is that the ocean is getting, the global temperature is rising. Then the ocean is getting warmer very quick. The ice sheets are shrinking, glaciers are retreating, snow cover is decreasing, sea level is rising, Arctic sea is declining, extreme events are increasing in frequency, ocean acidification is increasing. We are covered by three sides with ocean, but wherein these effects are not much for us. Why? Because the other part is completely Antarctic. We don't have anything down there. But here, as these people are near the pole, these impacts their daily life in a great manner or greater aspect. The impact is very high in each and every aspect. You just imagine most of the places here are islands. So an increase of ocean level on a yearly basis is a very big drawback for them. Like this, each and every point has a very big impact in their daily life. So that is why the, these are all the prime reasons, or these are the study based on which we had the necessity to go for some different systems. And the system which we have seen earlier was one such an impact of that. This is how it was changing. So 1901 to 2000 average, what is the temperature, how it has gone, how it is rising. This is the map. This is the map of the heat wave actually. This part, as I was telling you about the heat wave in last year, we feel like this is what we had in India, right? Wherein, if you see the whole world, the global map, this is very, very light, which means what we had is nothing. So even the very mild impact of what we had, we felt like this when it comes for the Asia alone is concerned. And when you compare it towards the whole world, you can see that the region of Europe is very, very high. This is what makes them work towards all these aspects. And also to acquire the knowledge of climate change. As I was saying, these are unpredictable. Day by day, we just make a study. We just do prepare things. Okay, this has happened in last 10 years, 15 years. Okay, from this we understand this. Okay, we will project like this. So this may happen in another 5 years. No, nothing. So based on the last 15, 20 years study, if you project for another 5 years, in 5 months it is changing. Just 5 months. This 2023 is not like 2024. 2024 is not like 2023. 2025 is not like 2024. So there is totally a diverse climatic condition. There is a totally a diverse, the pattern is totally different. To understand the pattern, we should know what is happening at a micro level or even macro level sometime to understand it better. But even then, even after those kind of macro studies, macro and micro studies, we don't know the projections or the forecast or what we plan will happen or it's going to change. So still that is going to be a very big question mark, but still we have to do what can be done. So we try for our best, but what comes, man proposes and God disposes. That's always the same. So it goes like that. So for this purpose, NASA has come with new proposals like you can see that the stratospheric troposphere response using infrared vertically resolved light explorer strive, and then Odyssey, and then Edge, Carbon One. These are all new proposals by NASA for observing the climatical changes. So what it does, the stratosphere troposphere response, what it does is that this mission would provide daily near global high resolution of temperature, a variety of atmospheric elements, and the aerosol properties from the upper troposphere to the mesosphere at much higher spatial density than any previous missions. So as I was telling, this is because the predictions are going wrong. So that is why they have launched all these things. You can, yes, the first one says, the first one is completely for the temperature monitoring mission. The second Odyssey is for the ocean dynamics and the surface exchange with the atmosphere. This satellite would simultaneously measure open ocean surface currents and winds to improve our understanding of air-sea interactions and the surface current processes that impacts weather, climate, and marine ecosystems. As we were dealing with the Arctic current change, this could help us in how or why the Arctic current is changing so quickly. You can see that this aims to provide an updated ocean wind data in less than 3 hours and the ocean current data in less than 6 hours once it happens. So this is done by University of California, and the previous one was done by University of Washington. And then the Earth dynamics. This would observe a three-dimensional structure of the terrestrial ecosystem of the complete glaciers and ice sheets and the sea ice. They are changing, and they are changing response to climate and human activity. With respect to the human activity, how they are changing. This particular edge is going to do that. This would provide a continuation of such measurements that are currently measured from space, ICSC2 and GDI, these two satellites. And this proposal is given by University of California again. And the carbon investigation, carbon 1 or carbon I, this would enable simultaneous multi-species measurements of critical greenhouse gases and potential quantification of methane, which could help study the process of drying naturally and anthropotropic emissions. This is purely for the vehicle emissions and other things. So this was proposed by California Institute of Technology. And when it comes for affordable and clean energy is concerned, we have multiple sources. Whatever you have said here, solar is there, wind is there, hydro is there, geothermal, bioenergy, nuclear, fine. All these things are affordable and clean energy. But are these really helping us? Is there any bad impact that is being given or we are getting because of this? Of course, yes. Of course, yes. Because the impact of solar plant on climate change, what it is that as we are very much aware, we are placing solar plants or the solar panels over the land or agricultural places in sometimes. So this changes the soil property drastically. When you have panels over a particular place, the soil fertility decreases. It affects the microbiological livelihood because the earth rays, the sun rays which are falling on the earth, which helps to maintain all these things, is being obstructed because of the planets. So therefore, what happens is that this affects the microbiological livelihood. So because of this, significant reduction in the water holding capacity of the soil also goes. Also, soil temperature is reduced. The organic matter that is available in the soil is also reduced drastically. This increases the pH value. So these are all drawbacks which we have because of solar plants. The increase in solar plants, the increase in soil degradation. So that's one important thing. And also then we can just think, okay, fine, if it is the case, then why don't we go for just put solar plants only in the deserts? No, it is also not the bad. Why? Because we should understand something. We may think the earth is very big, but it's very small, basically, And big changes affect somewhere in the southwest. So it's very bad. So it's not bad. It's not so that simple. If we install solar plants in Sahara Desert, it is going to affect the Amazons, right? This is a huge livelihood, but I'll just go by step by step. So this is all about installing solar plant on a desert, as I was telling. Yes, of course, we have 92 lakh kilometers of area. If we install there, we'll have enough energy, but that's not the case. Because when we install there, it automatically affects. This is a very big thing, actually. Yeah. Here it comes. I just wanted to highlight this. The most efficient of the solar panels which has been manufactured can only harness 50% of the sun rays. The most efficient panel that has been manufactured in the world is capable of only harnessing 15% instead on them. Again, beyond that, almost the 45%, sorry, 85% of the sun rays will go back to the atmosphere. It is being reflected. It's being reflected back to the atmosphere. So as per the calculations done in 2018 study, it says that only 20% coverage of deserts will make an average temperature rise by 1.5 degree. At 50%, it will increase 2.5 degrees. Since atmospheric temperature, we are saying that the global temperature increase, the global temperature rise will go up to 1.5 degrees if we have a 50 to 20% of the desert area. If you move that to a 50%, then it is going to be 2.5 degrees per year. So every year you will have an increase of 2.5 degrees. And also because of that, we will also lose the Arctics, the permafrost faster, the glaciers and all those things. They will just, they will melt away very faster. This will increase the water level, ocean level drastically. Because of this, automatically many islands will go away. Whatever problems we have been seeing on the slide number one as global climatical change, by just solar panels, you can just fuel them. And if you just install solar panels, if the world is gonna be completely destroyed in 100 years, by solar panel, we can make it happen in 20-25 years. So the solar panels are capable of doing that as well. So it's not all are renewable. So there are some ill effects in each and everything which we are not aware of. This has to be studied. This has to be taken into consideration. And also, the Amazon ecosystem will face a lot of drops. It will be less moisture because of when you place these panels in Sahara. This is purely speaking about Sahara. Nowhere else, the tropical cyclones will increase. These are all the effects which will cause by installing solar panels in a desert. Nowhere else. If you say because okay, solar panels, if I place in well, living places, I am getting this oil degradation, all other things. So let me go for deserts to install them. But when you go to a desert and install them, this will be the problem. So in all ways, in all the means and whiles, everything, whatever we say is renewable or clean or green or good, no, they are not only that, they have another face as well. So when it comes for the windmill, it is also the same. So nowadays we can see many places wherever previously there were no windmills. Now we have windmills in most of the places wherever it is possible to harness. We just installed a windmill. So what is going to be the problem with a windmill? See, what is the basic principle of your windmill? Simply, whenever there is a wind flows there, because of the wind flow, your turbine rotates, and then because of that, there is gonna be a generator which is gonna be coupled with that, and then that generates energy. So this is very basic. So what is the problem in that? There is no investment, free energy, clean energy. Fine, fine, fine. But what is happening because of that is this changes the wind currents. This changes the wind currents. You just imagine when you have a, even if you have a table fan in your house, how does that fan works and how you get wind? It is getting the wind from one end and giving to you. It is redirecting the wind that is moving or the air that is moving away towards you. That is how a fan works. And in the same way, if you are making a fan to rotate with the available wind speed, does the current change? Does not the current change? Of course, the wind current changes. You just imagine you're changing the wind current. Wind currents in the sense wind direction. That is what we call as wind current. So when you install many windmills and when you make them rotate, the natural wind current which is supposed to pass changes because of these windmills. Because of this, the rain is affected. Because of this, the rain is affected. The places which should get rain in time do not get. And because of the change in current, there is floods in some places. So this is again a problem which we have right now. Then comes your hydropower generation. Because of the previous effects, we have change in rain, and also nowadays we have that the pattern of rain is indeterminable. Even in our place, it is indeterminable. When it comes for the European countries, the condition is literally bad. Many countries are there which don't have rain at all for years now. Still, they are managing with all the other sources for their water resources and things. That's a different story. But the actual changing annual or seasonal patterns can impact the river flow, which we already facing. Not only this also affects the capacity of the plant. We have many hydro plants in our area. We know that when there is no proper water flow, that will affect the working hours also. Because of that, energy generation is also a problem. And flooding and intense rain. During flooding and intense rain, you will not be able to operate these plants as well. Because as the flood is going to be at a very high speed, the intensity of the water is going to be high, so this could damage the plant itself. So that's one thing. And then because of this, the air temperature is also increasing. Surface evaporation of the water, ice melting and out of the seasonal flows. Not many. See, when you sit and go through the demerits of all these plants, whichever we have been calling as renewable or best or clean, we have been seeing only on the good side. See, everything when it is small is good. When everything is too much, it's not good. Even if it is, even if it is like what to say, அமிர்தமும் மெய்யினால் நஞ்சுன்னு சொல்லுவோம். ஸோ அந்த மாதிரி சின்னதா இருக்கும் போது everything is fine. But when it goes to a larger extent, when you extend the scale, automatically the negative effects of them is also huge. So that part we are yet to come with. We have not focused or we have not looked into these aspects so far. So and we are not aware of that. Even now, after saying all these things, you would have you just I mean, what is this? Is this true? Or is this gonna happen like this? Is it true? How is this possible? This is not possible. This could be thoughts in the mind. Please go back and search. Now you have Google, you have many large language models. You can just search, will this happen if I put solar panels, if I cover solar panels in the Sahara, what are going to be the negative effects? You just go and search and then you will believe what am I saying. And also this one, is the windmills change the wind current? You just can check all these things and then you will know what are the impact which we have. And then, and also, this is another another problem we have, uh, we cannot say it as a problem, but the population, the urban population and rate did change. Uh, the urban population is keep on increasing. But we are very much aware. It is not only in a particular region across the globe. This is the same. So you can see that the worldwide in 2010, the actual urban population was only 3,486 millions, right? Wherein in 2020, it has already become from 3,400 to 6,700 million that has increased. But it is projected that when it comes to 2030, it is going to be like 4,900. So from 3,800, 486 or 3,500 to it's going to become 4,900, barely somewhere around 1,400 to 1,500 millions. So the population drift is going to be like this. So when everybody moves towards such urban conditions, automatically you can see the proportions. The population rate in change per annum is 1.8 from 2010 to 2020, where in 2020 to 2030 it's going to be 1.6. So you may think, okay, it is fine, the population change of rate is less. Earlier it was 1.81, but now it is 1.6. No, we just when it say 1.81, it was 3,500. But when they say it is 1.6, it's already 4,100 or 4,200. So 1.6% of 4,200 and 1.8 of 3,500 is going to be much more. So it's not just a percentage. When you come for the numbers, it's going to be huge. So how are we going to manage these? Because of this, what are going to be the ill effects? How are we going to face that? So yes, and again, when it further comes down to eco zones, economic zones, whether it's going to be a coastal lower or cultivated dry land portion. So the thing what we saw earlier was just a simple. You could have seen it as a simple development of module, which just get some data, send some data. But the reason behind going for such a simplified version is that we have to handle many things. We have to handle many things. We will have a lot of concerns. We will need a lot of such requirements is there. Say, for example, when you say now there is an urban place or a city which there you have a population of 300,000 people, so it's going to become 500,000 people. So from 300,000 to 500,000, 200,000 is going to be increased in 2 years or 10 years. So then automatically the space requirement, the traffic, the lighting requirement, the water requirement, everything is going to change. And also, lot of the things, factors you have to provide them transportation, you have to provide them with the good, the quality of air should be good. You don't have to put some firewood and burn something and then to get spoil the air when there are going to be a 200,000 people more. The carbon dioxide which they are going to exhale is already occupies most of the atmosphere. So in such a way, automatically the pollution by individual just exhaling will become more. So the breathable air that is available in the atmosphere is going to reduce because of that. So how are we going to manage that? Are we going to plant 100,000 trees in 1 year or 2 years and grow them up? It's not possible. So, likewise, yes, this is what I was telling you just a bit earlier. What are the challenges we have in that? One is we have to be climate resilience, water management, natural and climate hazard, green space management, biodiversity enhancement, air quality, place regeneration, knowledge and social capacity building for sustainable urban transformation. What does this mean actually? See, when the people becomes more, automatically they have to live, they have to adapt. The adaptability has to come in. So which is not so easy to bring with. So therefore, we need a lot of social capacity building programs for the individuals. Here we are not speaking of about some high school students or some engineering students or some other college students. Here we are speaking about ordinary people, laymen, every individual, whether they know to read, write or not, they have to live, they have to breathe. Even it could be a beggar, even it could be a whoever it is. This knowledge and social capacity building has to be given to all. And then how are we going to do this? For this, we need participatory planning and governance. It is not only the political leaders, every individual has to participate. In this, we have to bring social justice and social cohesion, health and well-being, and then new economic opportunities and green jobs. What does this green job mean by is that it is not picking one's job and giving to other one. It should not spoil anybody. Without hurting someone, you should get job. That's it. It is not splitting one job into two. It's creating a new job for one more person who's coming. So as I was telling, when the 300,000 is going to become 500,000, then you need to create 200,000 new jobs for these 200,000 people. So these are all the challenges. So this is what is first of all in everybody's hand, which is responsible consumption. So we need everything, but do we need multiple things of everything is what we have to think of. And then accordingly, we have to work on. There is no wrong in going home and then turning on the AC. There is no wrong in going home and turning on your heater. We don't require the AC to be turned on when we are traveling. So this way we can avoid them being turned on. Yes, of course, I agree with you. Everything is IoT, but why do you want to turn on your AC from your mobile and when you reach home? See, that is a very simple part for you, but you just imagine you just leave your home in the morning 9 a.m. and you just go back at the 9 p.m. in the night. So for these 12 hours, there will be a line which will be connected to your AC as well as your voltage regulator, which is going to consume continuously. Even the consumption is going to be very, very less as per your concern. One day you just consider as 1 unit. So if you consume 1 unit for just 12 hours in 1 day, in a whole month, you're going to consume 30 units. For one individual house, it's going to be 30 units. And for 1 year, it's going to be 360 units. Let it be 350 units per house. So if there is a 10 house in your street, then 350 into 10 is equal to 3,500 units. Then consider for your city. So the number is going to be huge. And when it comes for an apartment cases, we have 300, 400 apartments. Just imagine what is the consumption is going to be. So this we can use it for something else. So that is what the ultimate idea is. Everything. You see, this is another thing. Why instead of us being smart, why should we have everything else to be smart? We need a smart watch, we need a smart phone, we need a smart TV, we need a smart refrigerator, we need a smart I don't know why all these things has to be smart than be as being smart. I agree with you. These are all fashionable items, fine. But one smartphone is capable of doing everything. We know what are the capabilities of a smartphone. Then why should you do you want your even your TV and refrigerator? What is the necessity for your refrigerator to be smart or the washing machine to be smart? You just turn on your washing machine, it's gonna run and wash your clothes. Nothing is required. You just keep your food, it's gonna be there for the refrigerator. Why it has to be smart? So individuals has to think smart and decide whether it has to be smart or not. That's what is the responsible consumption is. This is not all my views. It's all from the climate act. This is all for the climate action and then responsible consumption and generation production. That is where this focus goes to. So this is actually the key necessity, or this made us think that we have to do something to ensure that we can do anything and everything with some small module which will be able to consume very less power, which will not require any external source, or which will not require anybody to keep on monitoring them. So we need a less data storage, we need less energy, we need less reproducibility should be more, and redesigning should be less, as it was a like sustainable solution. So this is what made us go there. That's all from my side. I think I've done justice for the session and the time given. So if no, the previous one actually I was planning for actually I thought it would go for the entire session, but the time was a bit less. But still, I hope I believe I have done justice for the session.
Yes, sir. It's a
Thank you for the
wonderful
opportunity.
presentation. Participants, any queries? Any questions? Participants, any questions? So, shall we conclude, sir? So, shall we conclude the session, sir? So,
From my side, I'm fine to conclude.
Okay, sir. Thank you. So, on behalf of the organizing team and participants, and I extend our sincere gratitude for your insightful session on AI and MLDL integration in hardware and communication system. Your expertise and clarity in presenting a complex and evolving topic made the session both engaging and enlightening. The practical perspectives you shared on integrating intelligent algorithms with hardware and communication frameworks provide immense pleasure to all the attendees and deeper understanding. We truly appreciate the time and effort you invested in preparing and delivering this talk. Your contribution has not only enriched our knowledge but also inspired us to explore innovative applications in this domain. Thank you once again for sharing your expertise and for being a part of this learning journey. Once again, I thank you, sir.
Thank you. Thank you for the opportunity.
Thank you, sir. Participants, I kindly request everyone to post the feedback form. The link has been posted in the chat box. Kindly be in the session. The next session starts by 7:30. Thank you all. After posting the attendance form, kindly wait for the next session. Be in the meet by 7:30. Thank you all.